let's start on Chapter 8, which is hypothesis testing. So 8.1 is all about the basics of hypothesis testing. So in science classes over the years, y'all have created hypotheses, and then you test them out. Well, using statistics, we're able to test it a little bit further and actually determine whether the hypothesis is true or not. So in statistics, a hypothesis is a claim or a statement about a property of a population. A hypothesis test or test significance is a procedure for testing a claim about a property of a population. So property of a population would be also known as a population parameter. So our population parameters would be like mu, the mean. A claim that someone could make is that the mean of the population of all temperatures is less than 98.6. That can be a claim. So it's a hypothesis. The population mean is 98.6 for temperature. P is proportion. Someone could make the claim, no one ever passes a statistics exam, or less than half of the people pass a statistics exam.
I'm going to kill you, actually.
All right, so proportion would be less than half of the people in class pass the exam. So the proportion of pass is less than half. That would be a claim. And then the last one is standard deviation. This one is harder to describe, and we're actually not going to test for standard deviation, but that is a population parameter. In an example, we have that 1,009 consumers were asked if they're comfortable with having drones deliver their purchases. And 54% of them responded with no. So 54% of people said they are not comfortable with having drones deliver their purchases. So let's say Amazon delivers your purchases by drone. Would you be comfortable with that or not? 54% said no. So using P to denote the proportion of consumers not comfortable with drone deliveries. So here is the claim. Majority of consumers are not comfortable with drone delivery. But do the survey results support this claim? So what the claim is that, how do we represent majority of consumers? That would be more than half. So more than half. So you're testing the claim that more than half are not comfortable with it. So we can actually find out if this is a good claim or not by testing a hypothesis. A way that we can do this in the calculator to test, and then we have to verify the results, is by using technology. So go to your calculator. We're going to go to Stats, over to Test, one proportion, Z-test. And so this is the hypothesized proportion. Don't look at that right now, because I just changed it. So P is our hypothesized proportion. So in this one, it's more than half. So you put in 0.05. The number of no's. How many people said no?
140,000.
Yep. And then N is our total sample size of 1,009. And then what are we testing? What is it not equal, less than, or greater than the 0.5? Yeah, it's going to be the greater than because we're saying P is greater than 0.05. So we're doing greater than symbol. And then we want to calculate. Then it gives us all this stuff. It gives us, well, actually, it's over here. I forgot. So it's over here. So what does this mean? It just looks like a bunch of numbers. We get a Z, we get a P, we get a P hat, and we get an N. So if we don't know what this even means, there's no way of deciding whether this is a true claim or not. So we need to understand how this hypothesis testing works and learn the associated terminology. Then we can make sense of the technology. So this is called H naught, which is called the null hypothesis. Because we are testing a claim, we need two hypotheses. We need a null, and then we need an alternate hypothesis. Alternative, sorry. Wasn't sure which word it used. H naught and HA, or sometimes they also use H1 as the same thing. H naught, H1. So our null hypothesis is always going to be the same. They're going to use equal. They're going to say a population parameter equals some value. This is true until proven otherwise. So it could be mu equals 98.6. Or the other example was P equals half. That's our null. We're saying it's true until proven otherwise. The alt one, that's the one based on the claim. So it's the one that we want to show is true based on the claim. So we're going to, like for that other one, I think it was P is greater than 0.5. So it's going to use one of those symbols. The alternative will. So part one, identify the claim. So in our last one was majority of people are not comfortable with drone deliveries. Part two, give symbolic form. You must write it like this. And then you have two hypotheses you have to write. Your HA or H1, which is your alt, which is what the claim is about. And then H naught, I like to put that on top actually. It's the one that has the equals sign. H naught is always the same. It's whatever it equals. Decide what your significance level is. That's your alpha, which can also be called your p-value. So usually we use 0.05. Sometimes we use 0.01. And then do your test statistic. So you either do Z or T. Those are the ones we're going to be using. So T was when you had degrees of freedom, you had the area in your tails. Z was the area to the left. Then you're going to test them out, draw a graph. And your two options for making a decision will be reject the null or fail to reject the null. And then restate in non-technical terms. So what we're going to do right now is only write our hypothesis. So let's look here. So back to this claim, we're only going to write the hypothesis. So back to the drone example. So in the drone example, the claim was majority of people are not comfortable with drone delivery. N was our sample size. What was the sample size on that problem? Mm-hmm. P was whenever we said the majority. So it's 0.05. Those are the no's. Q is if they said yes, they are comfortable. So that'd be also 0.05. P hat is going to be our sample proportion. The sample proportion was 54%. Remember they said it was 545 out of the 1,009, which was 54%. So that's 0.54. And X was number of no's. And that was 545. So let's just write our claim in symbol form. We did that earlier. It was P is greater than 0.5. Majority means greater than half. So all we're going to do right now is just do our H naught and our HA, our null hypothesis and our alternative hypothesis. Our null is always equaling that value. So P equals 0.5. HA, that is your claim. P is greater than 0.5. So let's not look at this. Let's go to the very last page that talks about, it's page 7, identifying H naught and HA. We're just going to do number 1 and 2. State the null and alt using symbolic notation and identify the claim. So go ahead and read that. All right, the null is that it equals the value. So it equals 0.82. What's the alternative? Greater than. Okay. The next one, we're not talking about P. What are we talking about on this one? Mean. So we're going to have to say the mean equals, what are we saying the mean equals on the null? And then what is the alternative?
Less than.
Yep. Okay, we're going to finish the rest of these in the next